So as of now here, we're going to be recording this. So today is February the 7th, 2024. And today we're going to be talking about spatial data queries. Like I mentioned to the people in class, we're taking a step back just because Dr. McGinn had a unforeseen circumstance that came up. So we're going to kind of talk the rest of what we were talking about late last week. And so when we were looking at late last week, because I want to start talking about exercise number 2 a little bit, because exercise number 1 is due at the end of the day today, right? Good. All right. How was exercise number 1? People like it? Easy, pretty straightforward. Pretty straightforward. Yeah. Very straightforward. And the exercise, just following the directions is pretty easy. Some of the things that I sometimes get frustrated with is I can't teach you to follow directions. So just start the first, the second, the third, the fourth, the fifth. If you have trouble finding the actual data, that's something that we need to set up. But once you kind of start going sequentially through those are things that are relatively easy to do. So we can apply what we're looking at with these types of maps right here. Because when you start working with crime data, you're going to be getting stuff like this. And most of you are going to say, this is a lot. And so last time we talked about how to run queries, because exercise number 1 just said, click on the little point. What are the little attributes that popped up? So it's getting us used to the taxonomy or the wording that we have to describe. We've got feature classes. We have this word symbology, and I heard you talking about the word symbology before. Okay, we have feature. So there's a difference between a feature class and a feature. And these are all going to be related to basically crime data as well. And then we hear these points, lines, polygons. You're like, we're not in math class anymore. We kind of are. But when we look at schools here, and we see schools, we see points, we see homicides, we see incidents, we see block groups. We see a lot of different things that have these different types of geometries. And I know that's a word that you talk about in 34, 35, as well as this class here. And here we kind of cut through everything and apply this specifically to crime as well. So when we start looking at queries here, these are some examples of queries right here. So we got Durham city limits. We have all the incidents right here. And whenever I'm in doubt, I can click on open attribute table, and I've opened up the attribute table. And so now I can query these. I can look for everything. And this says day of the week, WE. What do you think WE represents? Wednesday. Now, we're going to talk about other queries where I want to pick out the weekend. Because what's a weekend? It's a Saturday or a Sunday. Or Sunday. And we'll look at that query real quickly, because we're going to talk about logical errors and syntax errors. And these days, this software is really slick so that we can't really make a lot of syntax errors like typing in the wrong thing, but we can make a lot of logical errors out there as well. I have a column here called offense. So eventually when we go to the Durham OpenGIS website, we're going to download all these things here. And it's got address, it's got X, and got Y. This X and Y are really easy to calculate. Now, these aren't latitude and longitude. How do I know they're not latitude and longitude? How do I look at this number here? What do latitudes and longitudes go up to? What's the highest that latitude can go up to? This may be more a question for Alondra. What's the highest latitude can go up to? I don't remember. Is it 2,035,943? No, they go between -90 and 90. So South Pole to the North Pole. So these numbers are way outside of the scope for what we'd expect for. So these are what we expect for these angular units. So this is something different. And so we'll talk about how to turn these numbers into X and Y's that we can put on a map, because this is really easy. Or addresses. Have you ever typed in an address and it show up on a map before? We do this all the time with this. These little things here sit in our pockets, these very rudimentary GISs. Now we're going to run some queries, and we're going to talk about how to run some queries. Now I like going to little map, and on the map ribbon, it's got select by location, select by attributes, and we have something called select. But if we go to my crime analysis tools, it's got the same thing here. It's got select by attributes, select by location. So this crime analysis ribbon that you basically installed, it just puts together all the crime tools that you have. It just says, all right, I want this and this and this and this and this, instead of me going to hunt and peck and look for them, even though there's going to be a lot of these kind of sitting here, sitting over here under map. So under map or under crime analysis, we have something here called select by attributes. And so I can run these selection by attributes in which we generate an SQL statement. SQL stands for structured query language, and all it is just this language that interacts with the database. And you generate the queries. So now I've got input rows. This is the feature class. We'll talk about the selection type, and we'll look at this here in a little bit, but I have offense is equal to whatever. And so I've got the field. So I can download, I can click on this and I can say, all right, day of the week is equal to Monday. And I can click apply. And what pops up here? Day of the week is equal to Monday. And then these are all the crimes where the day of the week is equal to Monday. So there's about 5,000 out of 35,000, about 1 out of every 7. That makes sense, right? Because there's only 7 days of the week. And so get an idea as to what a correct answer is going to look like. And then I can do something like this. All right, of those, I want to create a brand new select from current selection. And so from those, I want to find everything where the offense is equal to arson. So we're just interacting with this. So now up at the top there, I have select from current selection. So it's not going to pick from all 35,000. It's going to pick from these 5,000. And so now I can say offense is equal to arson, and I'm going to click apply. And so now you can see I've only got 7 of them. Okay, 7 of these highlighted, and I got this little button down here. So now you can see everything, the day of the week is equal to Monday, and the offense is equal to arson. So both of those need to be satisfied. So there's lots of crimes out there that are Monday that didn't get selected. And so we can treat it as an and where they're both satisfied, or I can do select subset from current selection. And so when I start getting into some of these errors here, okay, when I start getting into some of these errors, a lot of times I'll say offense is equal to arson, and I'll click apply, and it gives me 0, and it's like, uh-oh, this is pretty smart here. But a lot of times if I have 0 to select from, it'll say, no, I can't do that, or whatever. Now, some other things we have. I want to pick out everything that occurred on a weekend. What's the definition of weekend? Saturday and Sunday, right? All right, let's do this. All right, so I want day of the week is equal to Saturday, and day of the week is equal to Sunday. All right, let me run this here. It gave me 0. Why? Why? What's going on? I'm looking. Exactly. What does and mean? It needs to satisfy both of those. And so it can't be a Saturday and a Sunday at the same time. So instead of and, what do we put? Or. And if I really wanted to, I could put exclusive or, but that's no big deal. So or. Now, and I don't want to get rid of this. This is select subset from current selection, which basically means I've got nothing selected, pick nothing from nothing. So I'm just going to get 0. But now when I go back here, I'm going to click new selection, and I should be right. And we're looking probably just off the top of my head, 9 or 10,000. And here we are. So now this is everything that occurred on a Saturday or Sunday that I can select from these. Now, what we're going to start talking about today is I see these things here like schools. Now I want to find everything, and now I can clear these. And so I have all these buttons here. That means clear, copy. So basically, if I copy these, I can stick these onto a clipboard and pop these into Excel. or SPSS or whatever you want to do. So I can just click this little copy button. This is fairly new because previously we kind of had to export these. And so I can do is type in a little like Excel right here. And what I can do here is cut and paste. Now that's pretty slick. And save it as a TXT or CSV or something that'll be, we can bring into R or SPSS or SAS. Or for me, for the most part, I can do enough statistical analysis within Excel to make myself dangerous. Now these are especially useful, but what I do a lot of times is I'll bring in all the block groups. Hey, let me look at all the block groups that are high crime. Let me get a different set that are low crime. Let's look at the income between the high crime and the low crime to see see some of the differences between them. Is there a difference in income or race or ethnicity or public housing or whatever some of those things are? So we can run something called like a two-tailed t-test. Does that ring a bell? Two-tailed t-test. Hey, the income in the high, crime rates is 27,000 versus 60,000. Those are statistically different. If it was 36,000 versus 35,000, well, it's a little bit more, but it's not enough to be statistically significant based on sampling errors and all that other stuff, sampling errors and sample size, which I don't want to get into. And even in geostats, I don't talk too much about. We just talk about how to run the formula or do whatever. But I want to run these spatial queries. And so now when I look at these crimes right here, and I can click the little clear button up here over in crime analysis right here. I'm sure there's a way there's a way that I can click clear over here as well. But here, now I've got schools. Now I want to look for schools within a certain distance of crime. Or I want to find all of the crimes that occurred within a particular block group right here. And so unfortunately, I know this is the block group that has NCCU, or this is the census tracts, but they're like right here. And so this is the NCCU campus right here with our block groups here. And so I can go and pick out the crimes that occur within this particular block group, and we'll talk about those. Now, when I open up those crimes or these incidents, and here's some homicides right here that I've added. Okay. So these are homicides. And I know in 34, 35, do we want to represent these with a green dot, or do we want to have something look a little nicer or easier on the eyes? Yeah, we can make something. So I can double click on this. And I know we were just talking about this previously, and I can click on symbology. And so I can type in a lot of different symbols here. I can type in the word murder. And yep, murder, and I got it. All right. Yep. Yeah. And so now this is where all the homicides are. All the homicides are. And you can type in anything. You can create your own symbology, bring it in. I'm not a very visual person, meaning I'm not great at making really good looking maps. I like doing the analysis, but you can make a whole living just making high quality maps. And you're the crime analyst, you're going to have to make something that an 8-year-old or a 98-year-old is going to understand. And I see something like this on a map, I know what that means. Definitely know what that means. And so we can put those there. And also with the schools, I just put the red dot, the red squares right there, but in reality, it can, you can make anything. Now, when we open up the attributes here, let me see what I've got here with schools, because eventually what I will want to do is there a certain relationship between how far are homicides from schools? Where are all the homicides? Where are all the drug crimes related to schools? Yeah, there's a bunch of schools up here. I just picked out all the schools within 10 miles of the census tracts right here. And these census tracts are just the census tracts that are entirely within the city boundaries. Okay, so I'm getting really specific really quickly, because if I start collecting data from outside and inside, you're going to run into issues of what we call logical consistency, because because this is part of actually all this stuff is part of the city. We've heard that term annexation before, but these data here are collected by the sheriff's office, and they're collected in a totally different way than the city. And so I wanted everything entirely within the city because it goes inside and outside. I'm combining data from two different data sources collected at different times, probably UCR versus NIBRS, and the different attributes, and it gets ugly. And this is just for a tiny little, Durham. And then you throw in NCCU, you throw in Duke, which have their own police departments. And so, imagine just for a county of 300,000 people, all the different agencies that are reporting there, because this thing's called incidents and it's not necessarily called crimes. And so when we look at the Durham Open website and type in the word crime, it's got DPD, DS, Durham Sheriff's Office, DSO. It's got all the different agencies that you can utilize data for. And so that gets really ugly, tricky quickly. So, but if I were to open up homicides, right mouse click, open attribute table, or even the incidents, because these are just extracted from these, do you see anything here that says distance from a school? No. All right. So how am I going to figure out how far these homicides are from schools? We're gonna have to create it. We can create a query, but I don't see anything here because I can do a lot of neat things right here. And so what we're going to be looking at today within the crime analysis, we've got selection by location, and under map, we have selection by location. So either on the crime analysis or the map, we have select by location. And once again, this is a little GUI, graphic user interface, where we generate a statement. Now, this statement, how does it know how far the homicide is from the school? Like, how does it really know that? How does it do that? What do I have right here? I've got real world coordinates. So it measures these things. These things are measured in real life, place, and space. And so now I've got my input features, which I said, all right, my homicides, are within a distance of schools. And I want to find everything within, 0.5 miles. And look at all the different units we have here. And so I've got meters, decimeters, centimeters, millimeters, statute, international nautical miles. What's a nautical mile? We hear those, you're on a cruise ship or a boat, they're going at certain knots. What's a knot? Close. How far is a mile? How many feet? 100 feet is a mile? 5,280. Does that ring a bell?
From second grade.
Yeah, from second grade. How many meters is that? How many yards is that? It's something like 1,760? Does that ring a bell? 1,780? I gotta do multiplication so early in the morning. But a nautical mile is 2,000 yards, 6,000 feet. Nice and easy to remember. So they're a little bit more. So if something, a boat is traveling at 30 knots, it's really traveling at like 33 miles per hour or whatever. So we got international yards, survey miles, survey yards, just.
What's that? The survey? What is that?
Survey, I think they're slightly different. I don't think there's really any difference between them. We're looking at like real fine precision here. We could look it up, but I don't really want to. I like working with the statute miles because but there is a difference between nautical miles. So I'm going to type in 0.5, okay, and I want to make sure it's miles because a lot of times meters and miles start and end with the same word, but how far is a meter? Meter. Not that far. It's like this is a meter, about a little more than 3 feet. And so half a meter is like this far. So we're looking for all homicides that are literally this far from a school. You're going to get 0 probably. Okay. And so a lot of times these are some of these logical errors that people make. So I want to find all homicides within a distance of public schools, those red dots right there. And I want to create a new selection. So none of this select by, current selection. So there's 59 homicides here. Should What do you think my answer is gonna be? Is it gonna be none of them? You think it's gonna be all of them? So every homicide,
So, not every,
okay,
but a good amount of them.
good amount, okay, so the answer's not gonna be 0, the answer's not gonna be 59.
Yeah.
Okay, so it's gonna be some of them. I might say half, I don't know. Okay. Oh, close. So 20 out of the 30, is that 3?
39.
39. So 20 out of the 39 occurred within half a mile of a school. Those red dots right there. So that's pretty neat, really neat. Okay. So we can run these queries here. Now we see here, there's nothing that says distance from a school, but it knows their spatial relationship in real world, real life place and space. And then the last thing I'll talk about here before I get into my little spiel here is that, okay, I want to find all of the incidents within this little old block group here. I want to find the NCCU block group right here and look at these. And so I can go through and select these. Now I'm kind of a geek here and I know the name of our block group right here. And so once again, I have some of these interactive tools here. Under map, I can just go and select this block group. And so if I were to right mouse click on this block group, you would see that 1 out of 100 block groups have been selected. And I happen to know, unfortunately, that we're block group 1303, or track 1303, block group 1. And so we talked a little bit about fixed codes. It's how we uniquely identify counties here. So now this is the NCCU block group. And once again, I can run a select by location where now I want to find, what do I want to find? I want to find all of the incidents that intersect with the block groups.
You say block groups, you mean by people standing on the block?
Nope. Block groups. Oh, cool. That's a good question. Now, block groups, we have counties, right? And we have subdivisions of counties are called tracts, and then subdivisions of tracts are called block groups. And so, see this little square right there, or that little polygon?
Yeah.
Within these polygons, we can count population, race, ethnicity, income, because if I were to look at income for the entire county, well, it's varied throughout different places. So now I know how many people live right here. I know the race of the people, percentage of college educated, or whatever you can think of that's collected by the census. Now, in addition, what we can also do is we can go over and count the number of crimes, calculate crime rate, all that other stuff. Now, crime rate isn't something captured by the census. But, well, we've got the crimes here, so we can run some things called spatial joins. And you can see some of the crime rates that we did for 2019, 2020, 2021. And we can look at kind of the change in crime. It was here, it was here, it was here. It's kind of stayed consistent. And so within that little census block group, and so we've got tracts, there's about 50 to 60 tracts within the county. And then we've got about 150 block groups within the county.
So it's basically like little individual areas of like different ethnicities, or it can be more we can see like
You get better resolution, yeah. Yep. So you can see here for this, where's my mouse here? For this one right here.
I just always think of a corner.
Yeah, block group. In theory, a block is literally like a block. Now, blocks are smaller. It's literally like this block here. And so a block group is just a group of blocks, and then a tract is a bunch of block groups here. But when we open up the crime here, so if we were to right mouse click, open up these incidents, we can see there's 226 of these crimes that occurred here, just right around the corner here. And if we look at the different types of crimes, block groups, then what do we have? Dupree Street, does that ring a bell?
Yes, sir.
We get East Lawson Street, South Roxborough Street, 55 North, Martha Street, Cecil Street, which is literally right out the end of the building right there. we had a
Death investigation.
death investigation, so someone might have just died or we'll see. And then we can sort these. Now, other things we can do with tables, we can right mouse click and see which one occurred the most, occurred the least, how many of them had the most or whatever here. That's what we call a summarize. I don't want to get too much.
But
What- Yeah,
we get all the good.
yeah, you're definitely, to me, this is all public information. Now, what do you all do with, or in this class, what can you do with it? That's the important thing. Because eventually your boss is gonna say, hey, where do the most death investigations or simple assaults occurred? What day of the week do they occur on? We can go through and figure all these things out using the offenses and the day of the week and everything else. So what we'll talk today about is a little bit of the spatial queries that we can run here, because I showed a couple of examples, and then when we get back to this, probably late next week, we'll kind of see how we can do this. So spatial queries are basically the process by which we retrieve data from a map theme by working with map features. Because like we saw before with homicides or incidents, it doesn't say distance from a school. What census tract is this located in? Because if you look at all the different combinations or permutations of this, you would never be over with. So the one advantage of attribute queries over spatial queries is that you need the map information, because in theory, you could do some really slick stuff with Excel and do all of those spatial queries pretty, not, I wouldn't say easily, but within the confines of different software packages. So we need a geographic interface to basically to work with the attribute data, which you can't do through attribute queries. So there's different ways we can pick things. We can just pick it. You notice like, hey, I'm a geek. I know where the NCCU block group is, so I'm just going to highlight it so it's highlighted in blue and just pick everything from there. So we can highlight those in a table, or we can start to look at different spatial relationships. What I said, give me all crimes within. Give me all crimes within a distance of schools, because those schools are represented as points, even though in theory a point is like a little polygon, but is it really going to matter the couple 100 feet across? Maybe, maybe not, but no one's really going to worry about those. And so we can use the control button. If I'm picking out certain schools where that, you just open up the table and start picking things right there, because I know if it's highlighted on the map, it's highlighted in the table and vice versa. That's the important thing. I can also pick something by cursor. What's a cursor? We hear that word a lot, right? Cursor, but what is it?
I want to say like it's like a search mouse.
What's that? The little pointy thing on the computer. So my little cursor, that's the cursor. So I can just mouse down on it and start clicking on stuff, And we can look for basically what we call events. And so I can click on the cursor and I can hold down the shift or the control to shift, click on individual features. I can select by rectangle. So I can just, all right, let me pick this rectangle right here and look at this. So I can select features from the active theme that are contained or within a particular object by lines, circles, boxes, polygons. Hey, let me just go pick out these, pick up these counties right here. But the most important thing is that we can look at spatial relationships. So it selects all features that fall within other features. Let me find all tornadoes within the state. Let me find all zip codes within the county. Let me find all crimes within half a mile of a school. Because some of these have logical spatial relationships, others of them do not have logical spatial relationships. Because remember, the end of the day, you are the user. The computer is just doing whatever you tell it to do. And so, like we said before, if you're looking for all crimes within half a meter of school, well, half a meter and half a mile, they start and end with the same letters, but they're two entirely different things. And so we can look at spatial relationships like all tornadoes within the state. Now, you notice a couple of points right here that aren't within the state. Look at that. Now, why is that? You see over here in North Carolina, I've got some points, but they're not highlighted. These are tornadoes. Why aren't these highlighted? Yeah, they're right outside the borderline. Exactly. They're right. Now, how would you reconcile that? How would you address that? So you say, all right, let me give me everything within a mile of the state. You could do that, but then we might include some of these right here. Or you might have to just go, all right, pick all these. Let me go and hand pick these by hand. Okay, go ahead. Because you notice all these areas here, when you break it down, and I know you were talking about this in 34, 35, if you were to zoom in, all these areas are just made up of little points that are connected by lines. That's all it is. And so these are just polygons. And these little points are called vertices, and the lines are called edges. And so you zoom in enough, you'll see those. What else we have? I have all zip codes that intersect with the county. And we'll look at some other different relationships that we can have. Or tornadoes within a certain distance of our county here. So we have different selection methods, okay? And this is what we get into the field of topology. Has anyone heard that term topology before? What's the relationship with polygons and points and all that other stuff? How about topography? Has anyone heard the term topography before?
Is that like a raster?
Yeah, kind of like rasters, but it's like the lay of the land. And we had a student, and the student who made that poster right there. A lot of times when you fill out an application, you write some nice general cover letter, and then you have to write a specific part of your application part. Part of your application might be something called like KSA, knowledge, skills, and applications, and someone gives you like a little GIS quiz. And for his GIS quiz, they said, tell me the difference between topography and topology. And so him and I worked on it together, and he ended up getting the job. But topography talks about the lay of the land. We got hills, undulations. So that raster that he was talking about is a representation of topography, where that topology is how do all the points connect to all the lines and so forth and so on. And so when you type in an address and go from one place to the other, you got to make sure you have the right topology. Because if you have like a dead end, well, the computer's not smart enough to know, hey, I can still drive through that dead end, or it's not really a dead end. It just says it's a dead end in my computer. The computer doesn't know the difference between those. So it looks at things like called dangling nodes or overlapping features and all that other stuff as well, that looks for some of those errors. Yeah, topology and topography. Yep, topology. And so now I can look at, all right, let me find every zip code that intersects with the county versus every zip code that's entirely within the county. Those are two different things. Intersect, entirely within. And we can find all crimes within a particular census tract. That's what we just did. So I want to pick out our census tract, which is 1303 census block group 01. So let me find every single point that intersects with this block group. And I can set up buffers as well. And so I've got incidents that intersect with block groups. I went through the trouble of picking it. Right? And I picked that out. I can look at something called proximity. What's the word proximity mean in general?
Like near.
Near, exactly. Okay. So what's the definition of near? When we look at crimes in schools, what's the definition of near? How do I put close into my computer? I'm very quantitative. So which is going to be your definition of close?
Close is like you put 0.5 on a map.
Exactly. 0.5 miles. Is that close for you? For you, it might be, 3/4 of a mile. Someone else, it might be 1/4 of a mile. So a lot of times when you start doing this research, or you start doing these projects or whatever, you got to stipulate, my definition of close was 1/2 mile. And a lot of times you might justify it with, all right, this person did 1/2 mile, this person did 3/4 of a mile, because a lot of times in our food desert research, well, what's close? A mile, mile, 2 miles, 3 miles. In rural areas, mile is nothing. Nothing. All right, so we can query crimes within a certain distance of a school. So I can find all crimes that occur within 1/2 mile of a school. And then we can find, so when I run it, basically, this is what all crimes within 1/2 mile of a school looks like. Now, we did that with homicides, but what do these little shapes look like? They just look like circles, right? What's the definition of a circle? What is a circle? The definition of a circle. It's getting real deep here. It's just a set of points that is equidistant from a center point, right? The middle. So if the school was in the middle, everything within half a mile. And so these little points right here,
All different points, all different sizes, like.
yeah, exactly, all around, and that's what we call a buffer, which we'll talk about. So like this little point here, it looks really close, but it might be like 0.51 miles, not 0.5. And so we need to stipulate those. And then from those, okay, I want to find everything that contains the word drug. And so I can select subset from current selection, and the offense contains the word drug. So now these are all drug crimes that occur within a half a mile of a school. So they satisfy both the spatial query as well as the attribute query, because we can combine those together. Because like the weekend problem, that was just a compound query using the word or. Right? Now we have to bring in the other types we have here. Alondra is sick of me talking about errors because a lot of times I kind of highlighted some of the different types of errors that we had, where that we can run syntax errors, where that, we've got weird symbols here. Our SQL doesn't know little $sign, it doesn't know the comma. Remember, Prop 2013 is greater than 1 million and less than 5 million. And it's like, well, what's less than 5 million? So these computers and these SQL statements need to be really specific. So these are called syntax errors. So a lot of times if you're writing like computer code is it's one or the other, If someone says something to me in another language or who's not a foreign speaker, I can get an idea as to what they're saying, even though the kind of arrangement of words and verbs and all those other things are going to be a little off, where that computer doesn't understand those. It needs to be that way. And so we also have logical errors, meaning the expression's going to run, but you will not get the results that you want. So if I have something like offense is equal to arson, and offense is equal to this, and offense is equal to this, well, it's going to say, well,
Too much.
there's too much. One is we need to change these to or because we're looking for an arson or non-negligent homicide or aggravated assault. And so they can't be those at the same time, even though we all use the word and. I'm looking for all arsons and some homicides and this, but the computer doesn't understand that. It understands or what. Another thing, we look at something like the median household income is less than 20,000 and the median household income is greater than 90,000. We have that word and there. And so like we alluded to before, and means satisfies all of these. Can you think of any number that's both less than 20,000 and greater than 90,000 at the same time? No. And when you run it, you're just going to get a 0. And a few people are going to say, oh, okay, it says 0. I'll put in 0 there, even though you're probably meaning to put the word or here, where we're looking maybe for extreme incomes across those 100 block groups that we're looking at. And so kind of addressing some of these. So a lot of times I usually will never give you a question where the answer is 0 or all of them. Okay, so if you get all of them or you get 0, it's probably, there's something wrong. Some other logical errors. Give me all crimes that intersect with high schools. Well, high schools are representative points. Crimes are representative points. So basically, what are the chances that a crime happens to be right on a point? Really, really, really small. Really small. And then other things like, let me find high schools that intersect with counties. All right, when I run it, basically every high school is going to intersect with a county in North Carolina. Oh, you need to specify the county. And the computer's not smart enough to say like, hey, specify a county. It's just going to say, sure, all the schools are within those. And then other logical errors we run into like decimal degrees. How far is a decimal degree? Sine, cosine, tangent, all that other stuff we don't want to deal with. Or something like 0.25 meters. Okay? Because a lot of times I get sloppy and I see it starts with an M and ends with an S. It looks, it looks like miles. It must be miles. Click, and I get 0, and I know why. So be careful with some of those. A couple other things I'll mention here, and then maybe when we come back, revisit this, we can look at like buffers and things like that. But for quizzes and exams, like when we run spatial queries, we can export features, because that's how I created homicides. I went through and ran a query of homicides, and I can just export them. So you can start working with your individual features, whether it's gas stations or homicides or whatever. And like, I know Alondra said this in one of our classes, when in doubt, right mouse click. And so you can export that. So I don't want to work with those 35,000 crimes. I'm just going to export out those homicides and make the little dead person lay in there, or the homicide or the arson or whatever I want to do, because I don't want to work with all 35,000 points and symbolize them as nothing. And so the utility of GIS is exporting out and creating your own feature classes and doing all this other stuff, because when you download this stuff from services, right? And I know you're working with services in the other class. In this class, I'm really still old school, where I give it to you and it's sitting on your computer, because, well, you can control it. You can't control services sitting in other places. And in some cases, they don't even let you export those out. So we don't do this. So what we can do here with Map Overlay, we can integrate different features with each other. The one thing I will talk about here is the idea of buffering. Okay, because buffer is going to be big in crime analysis, because has anyone heard of buffer? What's the word buffer mean?
When I hear buffer, it's like clean something up.
Clean something up. There's another term for buffer. I want to create a buffer between me and you. What's that mean? Distance, exactly. Now, once again, we talk about quantitative distance. Okay, what's that? A mile, 2 miles, 3 miles, or whatever. Because these are some of the analysis tools that we can create. But it's kind of like a cookie cutter, meaning, hey, I don't want to work with anything outside of the city, so I'm going to run a little like cookie cutter. Now, the cookie cutter for, the cookie cutter for the city of Durham is really funky looking, right? It's got these little pieces and whatever out there. So when we do data preparation, a lot of times I'll use that clip. We have selects, splits, identifies, unions. Union is basically like an or. Intersection. What's an intersection? What's an intersection? We got streets. What's the actual intersection meaning? Can you describe that to me?
Two streets go together.
Two streets meet. So there's actually sections of pavement that are both Lawson Street and Concord Street at the same time. That's intersection. And basically, it's Lawson Street and Concord Street. It's not one or the other. And so we have intersections. We've got unions, which treat it as or, and then we have these things like buffers. These are some other neat things. Because a lot of times when we start working with this stuff here, a lot of you say, I would really love to do this with the data, and I bet you at some point in time, someone has thought of that already and put it in here somewhere. And so even these tools right here, I've probably maybe used 2/3 of these. I've never used, I know what this is, Polygon Neighbors, I've never used that before. Symmetric distance, I've never used. Count overlapping features, I've never used. So there's a few of these I've never even used before, but at some point in time, someone thought it was useful enough to put it into a tool here. And so the one thing about buffers, which we look at, this is an example of a buffer. Okay, I've got my house right there. It's just a 1 mile circle. They're really, really easy to calculate. All it is a circle. Now, in reality, is this person farther away from my house? Like when you go type in directions right here, what do you care most about? Do you care about how far away it is or how long it's going to take you to get there? How long it's going to take you to get there. And that brings about a whole nother set of issues called network analysis. So, okay, this person I've got to drive right here, or this person around my house. Well, this one, there's a nice road that runs north-south. So this one, it might be further away in distance from one of these over here, but it's a lot closer in terms of distance, because that's what we care about at the end of the day. So these are examples of buffers, whether it's 5 mile or 1 mile buffers right here, and we create buffer zones. Okay, so buffer is really accurate where that we can create what we call multiple ring buffers. Okay, and these are multiple ring buffers around Wi-Fi transmitters. So we've got a number of Wi-Fi transmitters on campus. And so you can see within 100 feet, 200 feet, 300 feet. They're nice, pretty circles. They're concentric, meaning they have the same center. And then when they start to intersect, you can set up all the different parameters so that you can click and mess things up right here. But this purple area right here, all it means is that it's between 200 and 300 feet of a Wi-Fi transmitter. Does it say which one? No, it might be this one, it might be this one. It's just anything in purple is between 200 and 300 feet. We kind of understand this thing and it looks kind of pretty because there's ways that you can have these circles kind of, the actual lines show up and it gets really ugly really quickly. I can understand this. Or these are buffers around roads, which are getting increasingly complex, or buffers around polygons. And so you kind of start simple, you get uglier, then you get uglier here. And then we can look at the different variations of the buffers with that. So I've got a meeting at 11, so I've got to go prep for that, but we'll stop here. Dr. McGinn will be back Friday, and then we'll start working on exercise number 2. I don't have a due date for that. And then also, I've posted the exercise 1 is due at the end of the day. Okay, end of the day, you can use the online, you can use the either one there, but make sure it's turned in. Dr. McGinn and I get really flaky about making sure people stuff is turned in on time, especially when people have questions about exercise 2 and you haven't done exercise 1, we get really emotional. I get emotional. So, all right. So everyone have a great day and we'll see you later.
Thank you.
Thank you.
Are you done with the
You're not done yet. Oh, you know what you're doing. She's.
Yes, I don't get started because I'm lazy.
Are they for me?
No, that's for 4 things.
Oh.
And then. Repeat that class.